Welcome back for the chemical bonding and the valence bond theory. Here to understand further the shapes of the molecules, so and angles, bond angles and other things. So we should know about the orbital overlaps concept. So if you see the hydrogen molecule formation, both are 1s electrons. So when they are far apart, there is no attraction between any of the things. When they are coming closer together, the first hydrogen nucleus is having the more attraction on the second atom electron, vice versa. So here there is a, after formation of the molecule, there will be internuclear distance is a constant. How much that will be? That will be there will be overlap. If you see, both are in the s orbitals, far apart. When the bond formation, they will be very close to each other and there will be a overlap. The more the overlap, the more the stronger and we will see further afterwards. So there will be overlapping. The overlapping of the orbitals, not the electrons. Electrons are the fixed and all these things, they are the roaming, the orbitals are overlapping. The stronger the bond formation between the two atoms, the more the covalent, if it is a homonuclear or even heteronuclear and also. See, if it is a diatomic molecule, if it is a polyatomic molecule, in addition to the overlapping of these orbitals, there will be geometry also. So we'll see some of the IIT questions also, there will be interesting these things and all. And when these two atoms are very close to form a bond, their overlap may be positive or negative or zero, depends upon the sign. Sign means phase. Here don't get confused. See, in the physics you know that there is a interference, constructive interference and destructive interference, similar to that. A sine wave is overlapping with another wave, the amplitude will be different. If it is overlapping with the phase difference and all, it will be a destruction and so it should be a positive and negative overlapping and the zero negative overlapping. Why all these things to be read is the geometrical shapes also. Start with the methane. Just see how many carbon is 6. C is 6. That means 1s2, 2s2, 2px1, 2py1. 2pz is 0. That means nothing electron there because 1, 2 plus 2 plus 2, 6, 4 plus 2, 6. But what happens? These two all are in the same energy state. In the excited state, slightly here it will be 1, here it will become 1. Total 4 bonds. Why 4 bonds? Because it is first it will be in the first circle, second will be in all the same energy state. So 2s2 will become 2s1 and 2pz0 will become 2pz. So total carbon is forming 4 bonds. All are same the energy. Now, fine. That means 1 s orbital and 3 p orbitals. So total, if it is a 4 hydrogen, all the hydrogen are having 1 s orbitals. So yes, there is a 1 ss bond should be there and s and p, there should be 3. So the bond angle should be, the tetrahedral bond angle should be 90 degree centigrade. But not centigrade, it is a 90 degree angle. Okay, but if you see, it is a 109 degree and 5 minutes. 109 degree, 5 minutes is the bond angle. Why? That means it is not only the overlapping of this thing, there is something else is also there. This is a actual bond angles and all. Similarly in the ammonia case or in the case of the water and all, we'll see what is the problem. Now, how many types of overlapping is there? Types of overlapping. Only 2 types. One is sigma type, another is pi type, or pi also, like this also people will write. Sigma overlapping and pi overlapping. In the sigma again there are 3. Sigma overlapping there are 3. A, that is SS overlapping. S orbital overlapping. Second one is S and P overlapping. Third is P pi pi PPR PP overlapping. These three all everything is in the sigma. So if it is an SS overlapping, that means a small s and another is like this. Actually, these two will be like this. This is SS overlapping. In the SP overlapping, S is like this and P is a dumbbell. Remember all the time, it should be a head-on overlap. Head-on overlap means end overlap or head-on overlap. That means axial overlap. This is the axis. This is the axis. So this is also axis. So axial overlap. It should not be written like this. This is wrong. So this should be axial overlap or head-on overlap or end overlap, whatever it is. This is the normally axial overlap. It will be there. Head-on overlap also people will call. So what will happen? This one. This is S, and they overlap. See, I am not writing. May not be writing properly. This is overlap. Overlap with the dumbbell. This is a P. This is S. SP overlap. Okay. Now PP overlap we will see. Well, how P is the PP overlap. P is also one dumbbell plus another dumbbell gives dumbbell overlapping of dumbbell. Here it is a overlapping of dumbbell. It should be in the same axis, axial or head-on or like that. It will be this thing. Then these are all in the sigma bonds only. And sigma, if it is in the pi overlapping, pi will be in the parallel overlapping. Pi will be parallel. How it will be? Parallel means normally not S orbitals will not be in the pi bond. It will be in the p orbitals only. It will be like this plus another dumbbell overlapping. Overlapping will be here also it should be match here also. Top and bottom both it should overlap. Here also it should be overlap, here also. Not correctly drawn, but both the dumbbells, the top portion and the bottom portion, both should overlap. That is a pi bonding all the time. Normally it will be, it should be only the P bonds and not the SS. SS means there cannot be any pi bonding and all. Now, whether the sigma bonds are stronger or the pi bonds are stronger. Sigma is always stronger. Overlap is more. So sigma bonding is more stronger. Then what are the factors favoring the formation of covalent bonds? These are all covalent bonds only, not ionic bonds, ionic bonds. So as usual, if ionization enthalpy is more and electronegativity is in the higher state and all, they are not ready to lose electron. They are ready to form covalent bonds. Example Cl2 and F2 and all. So high ionization enthalpy and they not to lose the electrons. That is one criteria. Electronegativity should be high. Then these ionic compounds are more polar. They will dissolve in the polar liquids and all these things. But whereas unlike ionic solids, covalent substances are made up of discrete molecules held together in van der Waals forces, and they will be the solids, liquid, gases and all, bromine, chlorine and all. They have low melting points and not like the metal or the ionic compounds and all. But there are exceptions. One exception in the covalent bond is the diamond. Diamond is high. Diamond is the high melting point and all. Similarly, conductor, they are bad conductors, but again there is an exception. Exception is graphite. It is a good conductor. Two exceptions. High melting point, one diamond is there. Normally all other compounds are compounds of the covalent bonds compounds are the low boiling point, melting point and all, but diamond is one exception. Not a good conductors, but graphite is one exception. They are the dissolved in the non-polar solvents or organic solvents. Now coming to the polar means positive and overlap or negative overlap. This is only the pictorial diagrams you can see, and then we will go for the why these values are not matching. So that is now coming to the a new concept of hybridization. Hybridization, SATION, hybridization. Tomorrow we will see what is hybridization, what is SP hybridization, SP2, SP3, and all. Then molecular theory. Interestingly, this slightly listen carefully. So nothing is serious. Thank you.